Good day, everyone. For today's topic, we will have nanotechnology. So, before we define nanotechnology, let's define first the two words, which is the nano and the technology. Nano is a nanometer, which is a unit of length in a metric system. It is equal to 1 billionth of a meter, while technology is the making, usage, and knowledge of tools, machines, and techniques in order to solve a problem or perform a specific function. So, what is nanotechnology? Nanotechnology is the branch of technology that deals with dimensions and tolerance of less than 100 nanometers, especially the manipulation of individual atoms and molecules. Here are some materials of nanotech. Nanostructure, its size, and example material or application. 4. Cluster nanocrystals, quantum dots. Its size is 1 to 10 nanometer. And insulators, semiconductors, metals, magnetic materials. For other nanoparticles, radius 1 to 100 nanometer, ceramic oxides, buckyballs. And for nanowires, diameter 1 to 100 nanometer, then metal semiconductors, oxide, sulfides, nitrides. For nanotubes, diameter 1 to 100 nanometer, carbon dioxide, including fullerenes, layered chalcogenides. Nanomaterials have unique properties, but how can these properties be used to protect the environment? So here are the properties: galactic, electrical, magnetic, mechanical, optical, spherical, biological. So for catalytic, it can better efficiency through higher surface to volume ratio. For electrical, increase electrical conductivity in ceramics and magnetic monocomposites, increased electric resistance in metal. For magnetic, it increased magnetic coercivity up to a critical grain size, super paramagnetic behavior. For mechanical, improved hardness and toughness of metals and alloys, ductility and superplasticity of ceramic. For optical, spectral shift of optical absorption and fluorescence properties, increased quantum efficiency of semiconductor crystals. Spherical, increased selectivity, hollow spheres for specific drug, transportation, and controlled release. For biological, it increased permeability through biological barriers, improve biocompatibility. Now let's characterize nanomaterials. Origin of nanomaterials: it's natural, unintentionally released and manufactured. Dispersion it can disperse in gases, liquids, and solids. And it's a shape or structure: spheres, needles, platelets, and tubes. Aggregation state: single particles, aggregates, and agglomerates. And chemical composition: it's metals or metal oxides, polymers, carbon, semiconductors, biomolecules, and compound. Its surface modification: it's unrelated, is obtained in production process. It's coated, for example, conjugates, polymeric films. core shell particles, for example, spheres or capsules. The following are the applications of nanotechnology, or where can we use the nanotechnology. First, automotive industry. Second, chemical industry. Third, engineering. Fourth, electronic industry. Fifth, construction and medicine. We can use it in medicine. Another, it can be used in textile or fabrics or nonwovens, in cosmetics, food and drinks, household and sports or outdoor. The challenge of the used nanotechnology research to the past, present, future, and sustain. For the past, help clean up past environmental damage. For present, correct present environment problems, prevent future environmental impacts, and help sustain the planet for future generations. So, nanotechnology deals with our past, present, future, and help us to sustain our planet for the preservation and for the benefits of future generations. Nanotechnology has applications and also implications. First, application. Nanotechnology is reactive to existing problems or proactive in preventing future problems. But also, nanotechnology has its implications of interaction of nanomaterials with the environment and possible risk that may be posed by the use of nanotechnology. Applications: sensor, improved monitoring and detection capabilities, better controls information for environmental protection, risk management, more efficient use of materials, more data on waste, real-time accurate sensing of many compounds simultaneously at extremely low concentrations, frequently in hostile environments. Applications for treatment: cleaning up waste streams of contaminants, particularly those substances that are highly toxic, persistent within the environment, or difficult to treat, promise for cost-effective, specific, and rapid solutions for treatment of contaminants. Applications for remediation: clean up of contaminated sites with problems brought about by prior technologies and past practices. Applications for green manufacturing: atom by atom construction, less materials to dispose of. Two aspects. First, using nanotechnology itself to eliminate the generation of waste products and streams by designing in pollution prevention at the source. Second, manufacturing nanomaterials themselves in a buy-in manner. Both aspects involve use of environmentally friendly starting materials and solvents, improve catalyst, and significantly reduced energy consumption in the manufacturing process. Applications for green energy: nanoproducts such as solar and fuel cells could lead to commercially viable alternative clean energy sources, energy saving via lightweight composites, embedded systems. Grand challenged environment: Application for measurement in the environment. The vision, the unique property of nanoscale materials, will enable the development of a new generation of environmental sensing system. In addition, measurement science and technology will enable development of a comprehensive understanding of the interaction and fate of natural and anthropogenic nanoscale and nanostructured materials in the environment. Second, applications for sustainable materials and resources. Vision. A society that uses nanotechnology to transform the way it extracts, develops, uses, and dissipates materials and the flow, recovery, and recycling of valuable resources, especially in the use of energy, transportation of people and goods, availability of clean water, and supply of food. We're down to the last application, which is applications for sustainable process. Vision. Sustainable manufacturing process based on the use of nanoscale science and nanotechnology, integrated processes, and bottom-up assembly that can serve human needs and are compatible with the surrounding ecosystems and human population. And now for the implications. It implicates in the natural and global processes. Vision, the ability to understand and quantify nanoparticles in the Earth system processes in order to anticipate their impacts and thus optimize and integrate environmental sustainability and nanotechnology. Second implication is the implications in health and environmental safety. Vision, development of nanotechnology responsibly with full appreciation of its health and environmental impacts. Research challenges and needs include: first, develop high throughput or multi-analyte toxicological methodologies with focus on mechanism and fundamental sciences of particle toxicity and access to well-characterized nanomaterials for conducting risk assessment research. Second, better understand the diversity of anthropogenic nanoparticles through the development of nanomaterial inventory. Third, gain information on exposure to nanomaterials resulting from medical, occupational, environmental, and accidental release of nanomaterial with regard to the concentration as well as what form or forms the nanoparticles may assume upon release into the environment. Last, predict biological properties of nanomaterials through toxicological assessment of nanomaterials that includes relevant and scientifically appropriate acute and chronic toxicokinetics and pharmacokinetic studies. Other grand challenges and related issues. Metrology, fundamental to study of nanotechnology, grand challenge workshop. Energy, inseparable from environment aspects, initiative in hydrogen economy, production, storage, used in fuel cells. Smalley's Energy Challenge Grand Challenge Workshop. For nomenclature or classification necessary for environmental assessment, Cloven or Koliniwoski Proposal Vision 2020 NNI. The cell is a nanofactory. Uses natural ingredients, simple atoms, at room temperature, with small machines for assembling in non-toxic solvents, and the end-of-life disposal is accounted for. Nanotech is both top and down and bottom up like nature. What is the status of nanotechnology in the Philippines? The Philippine government has identified nanotechnology as one of its major areas of development, with significant allocation and R&D funding. The DOST, or the Department of Science and Technology, has appointed a technical panel for nanotechnology, which is tasked to oversee government funded R&D funding in this area. Applications of nanotechnology have emerged with increasing need of nanoparticles used in various fields of food science and food microbiology, including food processing, food packing, functional food development, food safety, detection of foodborne pathogen, and shelf life extension of food and food products. As conclusion to this topic, I would like to say that nanotechnology is a brand new technology that has just begun. It is a revolutionary science that will change all what we knew before. The future that we were watching just in science fiction movies will in the near future be real. This new technology will first of all keep us healthy because of nanorobots that will repair every damage that we have in our body. Secondly, it will give scientists the ability to manipulate the combination of atoms in an object and to turn it into a lighter, stronger, and more durable object than before, just by using carbon nanotubes that are known to be 100 times stronger than steel, and in addition to that, they are very flexible. Thirdly, nanotechnology will give us an abundant energy because it will transform energy more effectively. Thank you so much for listening and watching. Have a good day.